we discuss empirical rule. Hello.
Yes, sir.
And also we complete the discussion related to binomial distribution and Poisson also, no? I think we did not discuss Poisson distribution. Did we discuss this one, Poisson distribution? Yes.
No, sir.
In the binomial one, I think we discussed, no? This one, discrete probability distribution. No.
Yes, we covered that.
Yes, yes. Okay, then I think this source miss. Okay, then today our discussion is about Poisson distribution. This is a mathematical model which you can use to calculate probability related to discrete random variable. Then let's say as an example, if you want to do a study related to customers who use ATM machine, ATM machine, ATM machine. Let's say you want to do a study about customers visit ATM machine, let's say 5 p.m. to 6 p.m. Okay. Sometimes this may be the busy time. You want to do a study about number of customers visit ATM during 5 to 6 p.m. Then you can consider X as a number of customers visit ATM during 5 to 6. It may be 0, 1, 2, 3, 4, any number. We don't know how many customers visit ATM 5 to 6 p.m. Then if you can collect data from a bank, let's say you can consider 30 days, 1 month period. 1 month period. Okay. Then from the bank, ATM machine may be record. Sometimes you can get the number of customers who visit ATM 5 to 6 for last 30 days. Okay. Then based on these data, you can calculate average number of customers visit ATM. Then based on this average, you can calculate the probabilities using Poisson model. Okay, then the Px is the probability. Then you can see what is the probability that 0 customers visit ATM. 1 customers, 2, 3, 4, 5, any number of customers visit ATM during 5 to 6 p.m. The probabilities you can calculate using Poisson distribution. It is a mathematical model you can use to calculate probability related to discrete random variable. You can use the Poisson distribution when you are interested in the number of times an event occur in a given area of opportunity. Then here given area of opportunity mean time period. It may be a time period. In our example, time period is 5 to 6. We want to see number of items, that means number of, let's say, customers visit ATM during 5 to 6 p.m. Then the area of opportunity is a continuous unit or interval of time, or maybe volume, such as area in which more than one occurrence of an event can occur. These are the examples for Poisson distribution. These are the examples for Poisson distribution. Number of accidents occur in a road per day, number of birth, like this. Did you get the point?
Yes, sir.
Then we can apply the Poisson distribution when we wish to count the number of times an event occur in a given area of opportunity. The probability that an event occur in one area of opportunity is same for whole area of opportunity. The number of events that occur in one area of opportunity is independent of the number of events that occur in other area of opportunity. What do you mean by this? Then the probability that an event occur in one area of opportunity is same for all area of opportunity. Let's say if you consider 30 days and 5 to 6 p.m., the probability for, let's say, Monday is same as Tuesday, Thursday, Friday. There's no any variation. That's the one assumption. Then the number of events that occur in one area of opportunity is independent. That means the customers who visit ATM during Monday is independent from Tuesday. There is no relationship. Then probability that 2 or more events occur in an area of opportunity approach 0 as area of opportunity becomes smaller. That means now if you consider time period 5 to 6, you have a certain level of probability. The probability will decrease if you consider short time period, let's say 10 minutes. 10 minutes. Then this probability will decrease. And also we assume average number of event per unit is lambda. This is a symbol. Lambda means average value. when you do one example, it will be clear to you. Now this is the formula. You can use to calculate probability. Then X is the number of events in an area of opportunity. Lambda is the expected number. E is natural log value. Then in this distribution, mean is equal to lambda. Variance also equal to lambda. Then the standard deviation is equal to square root of lambda. Okay, then we can have one example here. Then we know in Sri Lanka, actually, the accident rate is very high. If you take 2016, there are nearly 3020 people died in the road due to accident. Then if you divide this by number of days, then per day average is 8.2. The average number of accident per day is 8.2. Okay. Then based on this information, we can calculate probability. It is very simple. And then here, I think you can read and understand this one. Please go through this part. Here, X is the discrete random variable. X is the discrete random variable. It is, we call that means in this example, it is the accident. Then the given area of opportunity mean in this example, day. Then we want to count the number of times an accident occur in a day. The probability that an event accident occur in one area of opportunity is same for all area of opportunities. And the number of event, that means accident that occur in a day is independent of the number of accident occurring other days. Okay, then the X is the number of accident in a given day. In lambda, if the mean number of accident per day, the probability of observing X event in a given day. Now this is the formula. Okay, then let's say you want to see what is the probability that exactly 4 accidents in a given day. 4 accidents in a given day. Then you can insert the given information into formula. Now X is 4, that means we want to see what is the probability that we have 4 accidents. Then the 8.2 is the lambda, it is given. E also constant value minus 8.2. 8.2 to the power of 4. 4 is the x. So this is we call 4 factorial. I think I explained this part. 4 is equal to then 4, 3, 2 and 1. Then with your calculator or maybe with the Excel, you can find the value for E and to the power of minus 0.82. Then the answer is 0.0491. Then this shows that the probability we are having four accident per day is 0.0491. Then to calculate the probabilities, actually we have a simple way through the Poisson table. Before we move to the next example, I can show the Poisson table. I can share with the Poisson table with you. Okay, I shared the Poisson table. Please check whether you have access for that. Okay, read this example. Yes. Then here, what is our random variable? Birth in a hospital. Number of birth. Number of birth. We can say it's, it may be 0, 1, 2, 3, 4, 5, any number. Then according to the available data, average number of births per hour is 1.8. That means value of lambda is 1.8. What is the probability of observing 4 births in a given hour at the hospital? Okay. Now this is the formula you can insert. E lambda is minus 1.8, 1.8 to the power of 4, 4 factorial. The answer is this. And this shows that if the average is 1.8, then the per hour, the probability we can see 4 birth is 0.0723. Okay. Then now to calculate the probability manually, sometimes it makes some time. You should have a calculator. But without having calculator, using Poisson table, we can calculate it. Then now I am going to explain how we can use Poisson table to calculate the probability. Then you can remember the lambda is 1.8. Then if the x is equal to 4, answer is this one. Lambda is 1.8. Can you see the Poisson table now?
Yes, sir, we saw that.
Okay, now this is the Poisson table. Okay, then in this table, you can see here lambda. Lambda. Then this value shows the lambda value. And then in our example, average number of births per hour is 1.8. It is 1.8 per hour. It is 1.8. Then here x is the probability. Sorry, x stands for the discrete random variable. It may be 0, 1, 2, any number. Then let's say you want to see what is the probability that 4 births per hour in a given day. What is the answer? Zero point 0.723. 0.723. It is very similar to the previous, the manual calculation. You don't want to worry about manual calculation. You can do the probability calculation based on the table. Then, but you should know how to do this exercise manually. No need to do, but you should know how to do it. Okay, then shall I give one more question? Let's say if I ask similar type question, then let's say lambda is 1.8. Then we ask what is the probability that x equal 4? Then answer is this one. Then let's say we can ask x is greater than 4. X is less than 4. Okay, try to get the answer for what is the probability that less than 4 births in a given day. What is the probability that less than 4 births or greater than 4 births? You can send your answer into chat box. I'll give you 5 minutes. The question is, in a hospital, the average birth rate per hour is 1.8. Then what is the probability that we can observe more than 4 births in a given hour? Less than 4 births in a given hour. Shall we do this exercise? Are you ready to do this exercise? Hello? Are you ready to do? I think you have to do it. I'll give you 5 minutes.
Hey, looking for trusted student accommodations near your university? But aren't you tired of endlessly scrolling on sites that...
In this video, we're going to talk about how to use the Poisson distribution formula